see. Okay, it's 1 o'clock. Let's get started. Welcome, everybody. It's 1 o'clock Central Time on a Tuesday. That can mean only one thing, which means another episode of our clinic. And let's begin at the beginning. I checked our Google document. There weren't any questions that anybody submitted before the meeting. So I'm not going to check right now, but there wasn't anything there. But nevertheless, I'm going to pause here and just ask for those of you who were able to join, are there any questions at this point? I mean, I'll ask that question many more times, but yeah, let's check in if there are any questions right now.
I have a question. Can you hear me?
Okay, go ahead. Yep.
Okay, all right. So I'm a student at the University of Minnesota, and a couple of the courses I'm taking this semester are parallel programming with CUDA, and also a spatial artificial intelligence course. And I'm trying to take MODIS 0.05 degree data, the coarsest resolution monthly files, MODC 13, I think, something like that. And we've figured out a way to read them in Python, and then we're processing them in C, C++. But I'm wondering if there's there's a fairly simple way to read them directly in Visual Studio C, C++, so we can avoid the Python steps, because moving the data back and forth between software and machines and largish data sets is kind of inefficient. So wondering how difficult that is, kind of for a starter, a beginner.
Yeah. Well, I mean, I'm off the top. I'm not an earth scientist. Off the top of my head, I don't know, but I can check with my colleagues if MODIS data is covered by EOS, because there is a high-level library called HDF EOS or HDF EOS5. I forgot if these MODIS files are they HDF4 or HDF5. Oh, Elena has her hand raised. Please go ahead.
Yeah, good morning, everyone. Actually, I was going to ask, are you working with HDF4 files or HDF5?
I think they're it's the suffix on the file is HDF.
HDF, it's probably HDF4 file, but one thing is, I'm sure we have example programs in C and C++. If you go to eos.org website, there are examples how to read them in C, C++.
Yeah,
okay.
Let me actually go there.
Yeah.
Is it HDF EOS?
I think it was, or maybe, no, I believe it was eos.org.
EOS.org.
They are EOS files, I do know that.
Oh, yeah, they're EOS files, yes. So there should be no, just a second here, I'll find out.
I think it's NASA EOS.
No, it's our website, Gerd. It's Jolie's website.
Oh, okay.
This is where you will have examples.
All one word, HDF EOS.
Right.
Yeah, here we go.
.org.
Right.
Right, and if you go to examples,
let me make that a little bigger.
MODIS. You can start, yeah, you see MODIS, the first link.
Yes.
Yep.
So here's example, right, and there are examples in let's see, Python, NCL, MATLAB, IDL, Python.
Oh, okay, so we don't have in C++, in C.
Oh, let's see, maybe more examples.
No, it will be more files.
Oh, right, but they are Python and MATLAB.
Right.
Yeah. So, I mean, technically, of course, it's possible, and yeah, to read them in C and C++. Most users, I mean, given the selection here, probably find it more tedious. But yeah, I think what we can do is we can get back to you. So we'll take this as a homework, and if you can give me your email address, then we'll certainly get back to you.
Yeah, I did on the registration, and my name is Tim Bodine.
Okay.
It's my direct email address. I have one at school and one at home. I use all the time. My home one, Tim Bodine, all one word, BODIN, at Comcast.net.
Okay. Right, and I will ask my colleague Jolie to get in touch with you. But
Mhm.
yeah, that's certainly, yeah. And you said it was the MODIS 0.5 degree
Yeah, 0.05.
resolution. Oh, 0.05, right.
Yep. It's actually the nice thing about that. It's global and it's one data set. You don't have to work with tiles. And I think it would meet our basic needs. So, but if it's going to take me a week, if it would take a week to learn how to read it and see, it better. We only have 4 weeks for the project, so better I just stick with Python probably.
Yeah. No. I mean, the data sets, I mean, if you had a chance to look at them in H5 dump or HDF view, they are basically, I don't know if these are grids or swaths or, oh, swaths, that's what it's, well, are you looking at swath or gridded data?
I think it's gridded because it's just a 3600 by 7200 matrix basically with several layers.
Right. So then it's probably gridded data and it's just a 2-dimensional array that you'd be reading. And yeah, okay, let's get back to you. Thanks for coming here and joining for sure.
Okay,
and
I'll jump off and see what see what I can learn from that site you mentioned.
Yeah. And Stephen had a comment. Steve, go ahead.
Right. My question was whether Windows was a requirement for reading desktop team boarding.
Yeah. What's your question, Stephen? Can you say it again?
If Windows operating system is a requirement for your project.
Yeah, I've got a laptop and a desktop, and they're both Windows.
It's unfortunate as of now.
Yeah. Linux is easier, I guess, right? Probably the easiest.
Yeah, I have this project that allows you to manipulate HDF5 files with the very similar syntax that you would do with Python. In fact, rather matching syntax with all the convenience features, but without the trade-off when it comes to performance. Currently, the currently working version runs mostly on Linux. It could run on Windows, but I do not support Linux. I do.
Okay. I'll jump so you can carry on with the rest of your call here.
Okay. Well, thanks for joining. Yeah, and we'll be in touch.
Thank you. Thank you very much. Bye-bye.
All right. Bye. Okay. Any other questions? Otherwise, we'll jump ahead and go through our usual motions.
No questions today.
Okay, thanks. Steve, you still have your hand up. Did you have another comment or question?
No, I did not. I just didn't put my hands down. Lower hand. Oh, I got it.
Yeah.
Thank you very much.
Okay. All right. Last week's highlights, first announcements. Again, registration is still open for the European HDF5 users group event, or HUG. Links to the website. It's going to be at either in person, but you can also join online. So I think you should register regardless whether you plan to travel there or join online. Please go ahead and register. Of course, you can get the tour of the either site only if you are there, although I'm sure they might actually have a video online, but it's not the real thing. Another thing that I just came across, I think it was published earlier this year, but I didn't want to miss it. There was a workshop, the DOE, the OSCAR division of the DOE had this workshop on the management and storage of scientific data, and some of us submitted sort of white papers to this. And so there are 2 artifacts. One is a PDF document that's here that collects all these position papers in one PDF document. So that's very convenient. I think each white paper is typically 2 pages, maybe 3 pages with references and everything, but it's a very interesting collection considering, I mean, the broad set of topics that was covered there. And then the organizers of this workshop compiled a technical report, and I linked that here. So please go ahead and check that out. So I just wanted to make sure that that doesn't get lost. And so it certainly slipped under my radar. I was at the workshop, but I didn't see the follow-up artifacts being published. So here they are. Okay. Any other questions at this point? No? Okay, then I'll go ahead. On the forum, there was one thing, I mean, there are lots of other interesting things that just came up before the meeting, but I didn't have time because I typed this up this morning. There was one question about, and that was sort of an interesting one. There was a user who noticed that he is obviously, he's using .NET, C# presumably, and he was using the PInvoke, that's sort of the A standard method in .NET to call native, unmanaged, as they would say in .NET, libraries. And the user was sort of going through the migration from a 1.8 version to a 1.10 version. And of course, the most significant change there would be that we switched from 1.8 to 1.10 from 32-bit to 64-bit handles. And what he found was, laudably, the user also had a unit test suite for their applications and so forth, and that was all great. And they noticed that one or some of the tests were failing, including one where they were sort of creating temporary files and creating HDF5 files. So one of the tests was failing, and they were wondering if this was a change in behavior of the file close function, the HDF.close in the .NET sort of wrapper or .NET bindings. But then very soon after posting this, the user actually got back and said, I found the issue, and they just had forgotten, because when you make this change from 32-bit to 64-bit handles, that means in .NET you would have to switch your handles, which are 32-bit, and in .NET or C# parlance, ints, to long, which are 64-bit in C#. And the user just had missed one spot where they had forgotten to declare something as a long now rather than an int. And after fixing that, all the tests passed. So that's good news. The only side comment here was, number one, what we recommend is that people, when they use HDF5 APIs in .NET, for example, to also use, or at least try to emulate HDF5 API types, such as we use that HID_T type in HDF5 for handles. Unfortunately, to my knowledge, in C# there is no simple equivalent of type def in C, for example, or also in C++. So we usually do in our unit tests a sort of hacky thing where near the top of a file, we just declare with this using declaration, we just say using HIDT, and then it's conditional on the HDF version, either as system int64, which would be the long in C#. System.int64 is a .NET type, but it's bound to long in C#. And likewise, system int32 is bound to int in C#. So by doing that, then in your code, you can declare something as HIDT or define something as HIDT. And then, okay, how likely is it that we will very soon switch to 128-bit identifiers? I would say not very likely, but your code will just be in a better state, I would say, by using, at least for the HDF portion of it, the HDF API types rather than bare bones ints and longs. And who knows, we might switch to doubles or something like that rather than 128-bit integers. And then there was a second comment. I think the user was pretty clever. He asked, well, let's assume for some reason I would not have found that issue as quickly. What would my options have been to discover which handle is actually open and so forth, doing some detective work? we have basically two calls, traditionally two calls, although we recently just added one call where you can look at any point in a program, in an application. You can ask, there's a call called H5F get object count, and these are URLs here. So if you click on them, it will take you to the reference manual. So you can get the abstract count, and but then also the other option, you can actually get a list of open handles, and then you could iterate that. And then as of HDF5 1.12, we have actually introduced this H5I iterate call, where you can then, depending on the type of identifier, you can iterate. Elena, sorry, I didn't see your hand up.
Yeah, just one comment. We will need to address the issue when library opens objects, and those will not be reported, unfortunately, through those calls, especially for external links.
So
there is bug filed for this, but it is a good question how we deal with this. It has to be addressed.
So you are saying that certain object types are sort of falling through the cracks here when I
right. For example, if you have external link and file is open through that external link and groups are open in that external file, they will not be shown up here.
Ah, okay.
So they will be closed when you close the external link group, but they may not be closed because of file closing degree. So that has to be sorted out.
Good point. Thank you.
This is unfortunate, and there is no easy fix for it, but it should be addressed.
Okay. Thanks for pointing that out. Yeah. Yeah, so that was that. And there are some other interesting forum questions. There was including one about fuzzing that came up today. We'll pick up with that next time. But before we go there, I think this was the only issue that stood out for me. Before we resume last week's discussion, are there any other questions so far? No?
Gerd, I just had one question before I forget about it. The first caller had asked Stephen about H5CPP on Windows. And Stephen said he did not, it's not supported yet. I was wondering, is the header only solution that doesn't include the compound type of HDF5 from structs, is that available on Windows if you were to just grab that and use it?
It's a complex question, if I may.
Sure.
Okay. It could work. There is something to do with strings that's the sort of could be an issue. Okay. I have a Windows machine somewhere set up for this one, and the rig that checks the new development across most available compilers, whoever donated, whichever compiler manufacturer donated a compiler to me. The new version, which I am coming out, will support Windows and the full STL, and is a different generation. So this will be the third generation iteration of it. Following paradigms that just recently became available in the past 3 or 4 years. Therefore, the code base, whatever there is right now, is not worth for me to look. It's that complex, as the new code base is on a different level. I think there will be one more iteration that will be on the same level as, say, Python or Java, but even the new iteration will be at the level that normally would use C++ and Python, and it will provide you the same convenience. If I answer that. So for now, the best is to compile it on Linux. The reflection mechanism does run on Windows. That's not a problem. That just outputs a header file. It's very simple mechanism with a simple graph processing algorithm. That will work on Windows. There are some
Okay.
internal differences between windows not following necessarily POSIX, and that could give a glitch. I think specifically with strings.
Okay. 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 Thanks, Stephen.
Okay, great, thank you. Now, let's just jump right back in. So last time we started briefly discussing this picture where I tried to sort of summarize a little bit. Let's say you are planning on using HDF5 in a cloud-based environment, and that could be a public cloud or a private cloud. Sort of what are your options with HDF5? And sort of we started briefly talking about this in the sense that I have my two users here, and my user one is sort of doing sort of the traditional thing. They have an application that is linked against the HDF5 library in some form, or they had a very clever developer that is familiar with the HDF5 file format specification and programs actually directly against the file format specifications, such as, if you remember last year's Hug event, for example, JP Swinsky gave us a presentation on his H5 Coro library where he is going directly to blobs, in his case, located in S3, or that same approach would obviously work with a locally attached or even a network file system. But usually, yeah, there is the HDF5 library in the picture in some form. And then you have user two, where they are, let's say they use a browser-based application or something like that. But in this case, they do not use the HDF5 library. So in that case, they use like the HTTP protocol to interact either with a web service or through some kind of serverless setup to interact with a sort of non-file-based representation typically, and where HDF objects, so to speak, are really represented as aggregates of S3 objects, for example. Elena, you have raised your hand, please go ahead. I think you're muted. Elena, did you want to say something?
Yes, sorry, I was muted.
Okay, go ahead.
So I missed, that's why I'm not sure the purpose of this one, but just for the completeness of the picture, it can be, for example, servers like OpenDAP. Are you considering putting it here? It's different, but it also allows web-based applications or applications that use different protocol like OpenDAP to access files in cloud or whatever in some storage.
Good point. I did not include that here. You would probably be using, also the HTTP protocol, and instead of HSDS, you would have, let's say, an OpenDAP server, and then that
DAP protocol.
Right, or the DAP protocol, exactly. And but then I think isn't the DAP protocol or these DAP messages, they are embedded typically into HTTP.
Oh, right.
So HTTP is the underlying protocol. I mean, you could use RPCs, I guess, in some form. Okay. Yes. No. Thanks for pointing that out. It's not included here, so that's there's room for improvement here, definitely. Yes, and I should do that just for completeness and for to help users who ask, well, where does OpenDAP fit in this picture? Okay, and then of course, if you, let's say, jumping back, or let's finish that HTTP modular OpenDAP. HSDS, as you probably know from John Reedy's presentations, HSDS can deal with HDF5 files that are really stored as blobs, as one large single object in S3 or in the Azure object store or other object stores. And but then obviously John also has defined a sort of call it cloud optimized representation of HDF5 objects, where rather than having one sort of blob that is formatted like an HDF5 file on the inside, you are really dealing with an aggregate of data and metadata objects, and then there is an open specification where you can read, okay, how John decided to represent HDF5 objects in S3, for example, or some of the other object stores. And then, there is a REST, meaning a stateless protocol defined how you discover groups and data sets and the dimensions and the type of a data set and so forth. That's all good. But then also, again, if you remember last year's Hug event, John also gave us a presentation about you can do this serverless with AWS Lambda, for example, in the Amazon cloud and so forth. But there are pros and cons, so there are trade-offs. This is just a picture that does not reflect, well, what kind of performance are you really getting with these different approaches? And there are trade-offs. Some of them are good for performance, some of them are not so good for performance. It really depends on what you want. But even in those cases where performance is not so good, you might be getting something that is important to you. For example, if you want like a multi-reader, multi-writer capability, you would get that with a sort of a services-like approach to HDF5. You would not get that at the moment with the HDF5 library. Now you could say, well, if I'm sacrificing performance, I could also sacrifice performance with the HDF5 library and implement the multi-reader, multi-writer capability. And that's true. And then the question is, well, which performance sacrifice is larger? And so that is a big topic. And I cannot sort of present you a sort of complete list of performance trade-offs and what performance you would be seeing. But so yeah, this is the purpose of this is really just to show different possibilities, and then as with everything, your mileage may vary. Okay, so that's on the HSDS side, or as John would say, the cloud native side, although again, it depends on what you define, what you mean by cloud native. But then on the other side here, if you stick sort of with a HDF5 library based approach, there are basically two extension interfaces to the HDF5 library, if you wish, at the top of the HDF5 library or the bottom of the HDF5 library. So at the top, you have this thing that we call the virtual object layer interface, where you are intercepting API calls, and then at that point you have full control. You can do anything you want. Whereas if you at the bottom of the so-called native virtual object connector, which is in the past we used to call this the HDF5 library, at the bottom of that virtual object connector, if you want to call it that, there is the virtual file driver interface, or VFL. So at that point you are saying, well, my expectation is that I'm talking to something that looks like a file, and looks and feels like a file. By that we mean, well, you can open it and you can close it. You can seek it, you can seek to an offset in the file. So there's the concept of an end of allocation and end of file, and you can read a range of bytes from an offset. You can write a range of bytes starting at a given offset. So this is what's in a way characteristic of this virtual file interface, which of course is something that wouldn't make a lot of sense with objects in a traditional object store. While, okay, for read operations, yes, you can do range gets and so forth. But in a case of S3, for example, or many of the other object stores, you cannot just write at a certain offset to one of these objects, you typically have to completely overwrite this object. I mean, you can enable versioning in some of these cases, but you cannot do the kind of random access as far as writing is concerned with objects in sort of S3, for example. And a lot of vendors, actually, even vendors who produce hardware appliances and so forth, they typically offer an S3 compatible interface. So it's not part of the S3 interface. There is no range put, let's call it that. There is no such thing. And that's pretty much it. So within this sort of maze, call it that, of possibilities, you really would have to carefully study. There are trade-offs. No matter which path you travel, there are trade-offs, and it may have to do with your use case for which direction you choose to go in. But all this picture tries to suggest is there are many different ways how you can approach this, including that this parallel file system, for example, could be implemented on top of an object store in the cloud, but also by the vendor. So if you have something like Intel Deos, for example, you would have an object store on top of which you can have a traditional parallel file system, but then also you can do things like that in S3 or the other public cloud object stores. Unfortunately, we are out of time. So if there are any questions, please hold them and come back next time, and we'll continue the discussion. Anyway, thanks for coming. And we had a pretty lively discussion today, which is good. I'll make a note on the calendar. And yeah, please come back next time and enjoy the rest of your day.
Thank you. Nice diagram. Bye.
Thanks. Bye.